Welcome everybody to another one of James's videos. Today we are going to be dealing with trigonometry grade 11, solving for 2D triangles using the rules. And today specifically we are going to be going through the cosine rule, or shortened the COS rule. Okay guys, so when we obviously approaching a question where we have to solve for 2D triangles, we have to look for the scenarios. Like I mentioned in the first video with sine rule, we had to look for all the knowns and unknowns. Here, COS rule works with two specific scenarios. So the first scenario that COS rule works with is called the V shape, or the side angle side scenario. Okay, and I've did a little bit of a picture here because I always see it as a V. If I've got the sides that make up the angle and I have all three pieces of this information, then I know the COS rule is in play. So let's look at this over here. I know this side, I know this side, and I know the angle that the two sides are making. And I'm trying to solve for the side opposite the angle. If we see this scenario, then the COS rule is in play. Okay? And the COS rule is a squared equals b squared plus c squared minus 2bc times cos of a. Now a squared is our unknown. Now when I was talking about that V shape, do you notice that this looks like a V? And remember I said over here in the picture that and that must be known. And that's all you needed to worry about. Okay, so now that that is known, we can then use the COS rule. So that's the first scenario dealing with the COS rule. The second scenario dealing with the COS rule is if we have all the sides are known and all the angles are unknown. So if you have this length, and this length, and you need to figure out an angle within your triangle, you can use the COS rule or cosine rule to be able to work this out. So what I've done here is I've basically taken cos A in this formula and I've made it the subject of the formula. That's all I've done. So I've brought the b squared over c squared over, and then I divided through by minus 2bc, which gave me this result here. Okay, so that's just a quick way of you knowing, okay, it's the same formula, just manipulated in a different way to be able to solve for different things. Okay, so let's put this into practice, guys. So I've got two examples here. I've got example 1 and example 2. Let's start with example 1. So what we're going to notice here, let's kind of see what we have. I've got this side, which I know is 6. I've got this side, which I know is 5. And I've got the angle in the middle. And what am I trying to solve for? I'm trying to solve for B, which is the side opposite the angle. So this is a V-shaped scenario, everybody. Here's my V. There's my V. I've got that, I've got that, I've got that, and I'm trying to solve for that. So I've got a V-shaped scenario which allows me to use COS rule here. So COS rule, let's write it out. A squared equals b squared plus c squared minus 2bc cos of A. Now obviously that is a generic formula. So let's make this formula a little bit better. Let's make it according to my triangle. So let's have a look here. See how I adapt it according to the scenario. The side I'm wanting to work out is b squared. So that would always come first. And then it's going to be, this is little a, this is little c. And this doesn't matter. Whatever you put first doesn't matter, as long as you continue with it going forward. And then it's cos of beta. So whatever you're trying to work out, guys, these need to be the same. Okay. It's very, very important that that is. So b squared, we don't know. So let's say a squared is going to be 5 squared plus c squared, which is 6 squared, minus 2 times 5 times 6 cos of 63. So this is what b squared is equal to. Let's put that into our calculator and see what we got. 5 squared, excuse me, plus 6 squared minus 2 times 5 times 6 cos of 63. That's giving me 33,76. And then how do we get b by itself? We just square root, hey? I'm going to put that in red. So we square rooting this side, we square rooting this side, and we go answer square root 5,81. Excuse me. 5,81 in this case units. Okay. And that's how we solve for AC, guys, using the COS rule. Everyone happy with that? Fantastic. Let's move on to the next example. Now the next example is asking me to solve for this triangle. So what it's asking me to do is basically work out everything that hasn't been worked out already. So let's see what scenario we're dealing with. We're dealing with the second case scenario here. Why? Because don't we have all the sides? And isn't that from the above scenario? We have all the sides, which allows us to use the COS rule to work out an angle. So let's see. Let's write out our equation. COS of A equals A squared minus B squared minus C squared all over minus 2BC. Like in the previous one, let's make it specific to the letters in our triangle. So let's change this up. Which angle do we want to solve for here? We can choose. Let's solve for H first. Okay, so then that's going to mean that is going to be an H, which means the A is now going to change into small h, which is here. Small g is here. Small f is here. So let's change the letters. Now that's going to be H, and we can start with F and then G and then F, G. Now my formula is directly related to the question at hand. So now we can work out COS of H. So COS of H is going to equal H squared, which is 6 squared, minus 5 squared minus 4 squared, all over minus 2 times 5 times 4. Okay, so therefore COS of H equals, put it in our calculator, so fraction button, excuse me, 6 squared minus 5 squared minus 4 squared, all over minus 2, 5 times 4, I get 1/8. It's a very small angle, but we haven't worked out the angle yet, guys. We still need to shift COS. So H is going to be COS to the minus 1 of 1/8. Therefore, angle H is going to equal shift COS of 1/8, which is 82,82 degrees. Okay, so we can go ahead and sub that in here. 82,82. Okay, now guys, very nice. Whenever you do use COS rule, the rule is that you only actually have to use it once, because after you've used it once, you actually have enough information to then use sine rule, okay? So we've solved for H, we want to solve for F and G. So let's solve for F now. So if I wanted to solve for F, I can use sine rule here, can't I? So I can say, I'm wanting to solve for this, I've got this, I've got this, and I've got this. So I have an ordered pair. So I have 3 knowns, and I've got 1 unknown. So let's go ahead and work this out. So we're going to say, because we're working out an angle, we can start with the angle on the top. So sine of F over the opposite side of F, which is 4, is equal to sine of 82,82 all over 6. Therefore, sine of F is going to equal, and what I can do here is I can times both sides by 4. So now I've got 4 sine of 82,82 degrees all over 6. Therefore, sine of F equals, let's put that into our calculator. So if you don't press the on button, I think even if you do with these new calculators nowadays, they do save it. But your last answer, which is the 82,82 with all its decimals, is stored in your calculator. So you can go ahead and say 4 sine of A and S in your calculator over 6. And that gives me 0,66 reoccurring. Again, use the stored value in your calculator. We're now going to go shift sine in order to get the angle of F. So therefore, angle F equals shift sine of my answer, which is 41,41 degrees. Okay, so now we've got that angle as well. What are we missing, guys? We're just missing the third angle of the triangle, right? And how do we get that? How do we get the third angle of the triangle? Very simple. Sum of angles in a triangle add up to 180. So therefore, we don't even have to use trig here. We can just go angle G is equal to 180 minus the 41,41 minus the 82,82 degrees. Let's see what that gives us. 180 minus 41.41 minus 82.82. And that's giving me 55,77 degrees. And that's what this angle is. Okay, so that's what we've done, guys. We have solved for everything in that triangle. So that was my F, that was my G. Okay, so we see how we can use actually more than one rule in one question. Okay, and then also just about looking for those scenarios, right? You need to look for the V shape. You need to see, oh, I've got all the sides. That allows me to use COS rule. A little bit of a hint as well, guys. Just remember that these rules are mainly designed for non-right angle triangles, okay? That's why they were kind of invented, or that's why I think they were invented, because we can always use normal SOHCAHTOA for our right angle triangles. So when we're dealing with non-right angle triangles, these rules are in play and these scenarios we need to look out for. Okay, if you liked the video, guys, please click the subscribe button below, and all these notes are available on the James book, in the James book. So if you are keen for a copy, please let me know. Drop us a message, go onto the website, get in contact with us, and we'll make sure you can get a copy of that. And yeah, hope you enjoyed the video. Please stay tuned. We'll be doing the area rule next, and then we will do some harder examples as well. Thanks, guys.